We want to look at your notes for today. It's found here in your classwork for today's date under notes. It'll take you to our notes and teacher made. Here's our standard. All this week we've been working on adding and subtracting and multiplying polynomials. I want to look at example number 1B. Number 1A is already worked out for you in your notes. And if you just jot down 3x plus 2y, be sure to indicate that that's squared. One of the mistakes I found some folks do, and it's a very common mistake, is they think, well, I can square the 3x squared and I can square the 2y, but actually you can't. That's not the way it works. Remember that an exponent means that I'm taking whatever's inside that parentheses and I'm multiplying it times whatever's in that parentheses a second time. That's what a power of 2 means. So I would want to rewrite 3x squared plus 2y with the square this way. I would want to rewrite it as 3x plus 2y times 3x plus 2y. That will keep me from making an error. Now, there is a pattern, and there is a shortcut way to multiply it. But if I go ahead and write it down twice, then I know to distribute twice and to multiply it the same way that I've been working every other problem. And likewise, again, my goal here is to be pretty accurate. So I multiply 3x times 3x. We already know because we've been doing this all week. That's 9x squared. And we multiply 3x times 2y. So that's going to be plus 6. I'm going to put the variables in alphabetical order x, y, just like that, 6xy. Likewise, when I multiply 2 times y times 3x, I get 6yx, but I need to put those again in order. It doesn't matter what order the variables come in. So I'll rewrite that as 6xy as well. And then my last term is 2y times 2y, or 4y squared. Well, the last step is to combine like terms. I go to 6xy and 6xy. That is a 12xy plus 4y squared. So that's my answer, 9x squared plus 12xy plus 4y squared. Now, we would call this, and we would give it this name. So write this down. This is a perfect square trinomial. Now, in just a very common sense, realistic approach, we know that there are perfect square integers. For example, 9 is a perfect square, right? 16 is a perfect square, right? 25 is a perfect square. Well, those are easy to recognize, and they have, we just are familiar enough with their multiplication facts to know that those are perfect squares, and the perfect squares go on forever. But that is a limited set of numbers. Well, when I look at 9x squared plus 12xy plus 4y squared, it is also a perfect square trinomial. And there's some key features. Now, they're a little less obvious to see, but let me show you what those key features are. In fact, we can get to where we recognize it. Let me show you. First of all, 9x squared is a square number, right? Perfect square, 9. Square root is 3. X squared, square root is x. Okay? Then notice that the last term, 4y squared. Again, it's another perfect square. Square root of 4 is 2. Y squared. So those are some indicators that this is a perfect square trinomial. But there's one other part. The middle term is the final indicator, the one that we really need to pay attention to. Remember I said the square root of 9x squared is 3x. And that the square root of 4y squared is 2y. Remember that? Now, if I multiply those two together, okay, I get 6xy. If the middle term is the square roots times 2, okay? 6xy times 2, 12xy. Then that's the quality of a perfect square trinomial. Now, it's not amazingly obvious right up front, so it's something you'll get used to using, but it is recognizable because of those things. Remember that middle term there is plus 12xy. And so if I take these square roots, multiply them together, which is 6xy times 2, I get 12xy. And so it has a form. Perfect square trinomials have a form. Let's look at a couple more problems. Write this one down. This is problem number 5 in your notes. So it is 4 plus x squared. Let me let you write that one down. And while we're at it, let's go ahead and let you write number 6 down. I'll give you just a few moments to work those on your own, and then we'll come back and determine whether or not you have a question about it. Let's see what this looks like then when we work these problems. First of all, I'm going to always rewrite it. It's 4 plus x squared times 4 plus x squared. So I'm going to do that absolutely first. 4 times 4 is 16. 4 times x squared is plus 4x squared. X squared times 4 is plus 4x squared. And the last one is going to be x squared times x squared, which is x to the, remember we add those exponents, x to the 4th power. Okay, so I'm adding two middle terms. It's 16 plus 8x squared plus x to the 4th power. Remember, the square root of 16 is 4. The square root of x to the 4th is x squared. 4x squared times 2 is 8x squared. That's a perfect square trinomial. Has to be anyway, because that's what we did. We took a binomial and squared it. Look at number 6. Same thing. I'm going to rewrite those two. And I'm going to multiply x times x. And now it's negative x times negative x, so I get a positive x squared. And then a negative x times 3 is negative 3x. And then 3 times negative x, negative 3x. And 3 times 3, positive 9. So simplify that out. X squared minus 6x plus 9. Ask you a question just to think about for a moment. In a perfect square trinomial, okay, the ones that we've looked at, will the first term of the trinomial or the last term ever be negative? What do you think? Will the first term or the last term ever be negative? Oh, no, it started recording. So the answer to that question is that the first or last term will never be negative in a perfect square trinomial. The reason being, and we just figured that out, is I can't multiply something times itself. In other words, I can't square it and get a negative number. So it'll never be negative. Well, let's look at a different type problem now. And it's kind of similar, but it's a little different as well. This is example 3b. So write this down, please. It is x squared plus 2y times x squared minus 2y. Here's what I want you to notice. It's not a perfect square because one is positive, the other is negative. But outside of that, notice that x squared here, are you looking? And x squared here, that's the same. And outside of the plus and negative, 2y and 2y are the same, except one's positive, the other's negative. All right, so let's talk about what's that going to look like when we multiply, okay? So x squared times x squared is going to be x to the fourth. Write that down. We know that. X squared times negative 2y will be negative 2x squared y. And then positive 2y squared will be positive 2x. I'm going to put them in order again, 2x squared y. And then negative 2y times positive 2y will be a negative 4y squared. All right, so I've got some simplification to do here. I need to combine like terms. And so negative 2x squared y and a positive 2x squared y, they cancel each other out. And I'll be left with x to the fourth minus 4y squared. Wow, the middle term left out, we were left with a binomial. We multiplied two binomials and we got a binomial. Well, this is a special case, a special condition, and we call it a difference kind of show you where that word comes from, why we said difference. There it is. Subtraction, that means means difference. Difference means to subtract. So we call it a difference of squares. You might want to jot that down. Again, the difference comes from the fact that these two are subtracted when I get my answer. And the squares portion comes from the exponents. That's a square, and that's a square. That's a square because the square root of x to the fourth power is x squared. X squared times x squared gives me x to the fourth. And 4y squared is a square because the square root of that is 2y to the first power, because 2y times 2y gives me 4y squared. That's what we call a difference of squares. And always, this product, this x squared plus 2y times x squared minus 2y, will always give me a result that has a negative sign in the middle of my binomial. It's always going to be negative. The reason being for that is you can't take that last term and multiply positive times negative and get anything but a negative. So let me let you try one. Write this one down, please. This is number 11 in your notes. Okay, and it's simply 7 plus x times 7 minus x. Write that down, please. So, 7 times 7, 49. 7 times negative x, negative 7x. X times positive 7, positive 7x. And positive x times a negative x squared. Middle terms will drop out. And I'll have an answer of 49 minus x squared. A difference of squares is the easiest to recognize. Why? Because it'll always be a binomial. It'll always have a subtraction sign. And, in the name, difference of squares indicates it's got that subtraction sign. And it'll always be a first term that's square and a last term that's square. A difference of squares is easily recognizable because of those things. So those are two special binomials. Now, we don't really have learned anything that we hadn't already seen, but what we have learned is that these are some special cases, and we can use the knowledge we already have to solve those special cases.